Hey, let's have a look at partial pass-through JMS IBM MQ mocks and how Traffic Parrot with these types of mocks can help you solve some typical QA environment issues. Some of those issues that we'll be tackling are, for example, environment availability issues. Once a week the environment is down for a few hours. Environment instability. For example, a few times a week the environment returns unexpected errors due to core banking system failures. For example, conflicts between teams where teams use each other's logins in the test environment and modify each other's test data, stepping on each other's toes. Or test data issues like test data setup time is quite lengthy. For example, test data setup requires days or weeks of work by a specialized team once a month. Or multiple teams use test data and you're burning through the test data. For example, store item purchases in the test environment take down the stock quantity to 0. So you purchase 1, 2, 3, 4, 5, you get to 0 and you can't test anymore. Or you get limited test scenarios. For example, selected test scenarios are missing in the QA environment. How would we solve this problem? The long-term solution is to stabilize your shared environment, so they're stable, there's no unavailability or intermittent failures, and rely less on testing in shared environments and more on a testing pyramid or a testing honeycomb or some other testing architecture. What we recommend is having a look at the practical testing pyramid on Martin Fowler's blog, the honeycomb testing of microservices from Spotify, or the article we have written on InfoQ on 12 testing techniques for microservices. And Traffic Parrot would fit in nicely to all of these long-term solutions. However, there's a quick fix to alleviate those critical issues. Let's have a look at this sample QA environment where we've got a finance application that we're testing that's connecting to a middleware IBM MQ and then the core banking system, which has got a lot of issues, like the environment goes down, it's unavailable, there's intermittent failures, there's test data setup issues, etc. Okay, so in order to have this quick fix to alleviate these critical issues, we're going to implement partial pass-through or proxy JMS IBM MQ mocks with Traffic Parrot. So the finance application will be connecting to Traffic Parrot, which will be proxying traffic to this IBM MQ broker and sometimes returning the mocked data. Okay, so why is that good? Well, the environment is not unavailable anymore. The partial mocks are under your control and they're always available. Same with stability. Partial mocks are stable. There's less conflicts between teams, and the test data setup and burning through test data issues are almost eliminated because you can set up your partial mocks in an automated way, and you can reset the test data automatically with a click of a button, or actually automatically through APIs or periodically, etc. And you can set up more test scenarios in these mocks because they're under your control. So what we'll be looking at in this demo is creating a partial pass-through proxy mock through Traffic Parrot. Okay, and we'll be doing that with JMS IBM MQ. The sample request response pattern we'll use here looks like this. We're going to have a mobile onboarding microservice and mobile network hardware application running in the backend. Okay, and this application's got a lot of these issues that we've talked about. It's unavailable, the test data setup is an issue, etc., etc. We'll focus on one of those in this demo today, which is setting up test data for some scenarios that are not available in this environment. Okay, so the way this application works is the mobile onboarding application sends a request to the provision request queue on IBM MQ broker, the middleware, which gets consumed by the mobile network hardware, and then it does some processing and returns a response to provision confirmation queue, and that message gets consumed by the mobile onboarding application. I'll show you this mobile onboarding application in a minute. Firstly, however, let's have a look at how we could mock these JMS IBM MQ response messages. What we'll create is two additional queues, mock queues. So mock provision requests next to the provision request queue, and mock provision confirmations queue next to the provision confirmations queue. And in a mocked scenario, the mobile onboarding application will send a request to the mock provision request queue. It will get consumed by Traffic Parrot. Traffic Parrot will load up the data from its database and send a response to mock provision confirmations, which gets consumed again by the mobile onboarding application. Okay, so in this scenario, there's no communication with the mobile network hardware, and we've set up test data for our hypothetical scenario. Okay, And at the same time, we'll be able to configure traffic parrot at the same time for this scenario, the pass-through JMS IBM MQ request and response message pattern. Okay, so in this case, we've still got the mock configured in traffic parrot. However, we'll be sending a different phone number to the mobile onboarding microservice, not one that is configured in the mock. So you see, we're sending on the left here, we're sending 444-555-666. However, the mock is configured with the telephone number 111-222-333. So what happens is the mobile onboarding application sends a request to the mock provision request queue. It gets consumed with traffic parrot, and then traffic parrot looks at its mocked data and realizes, hey, I don't have a mock for this phone number 444-555-666. I've only got a mock for 111-222-333. So I'll just forward it or pass through this request to the real provision request queue. That gets consumed by the real backend, processed and sent back to provision confirmations queue, and then forwarded by traffic parrot to the mock provisions confirmations queue and consumed by the mobile onboarding application. These two diagrams show us how traffic parrot is configured to work simultaneously in a pass-through mode and a mocked mode, okay? And depending on the data you send to the mobile onboarding microservice, whether the data is mocked on traffic parrot, like in here, the number 111-222-333 that is mocked in traffic parrot, or the mobile number 444-555-666, which is not mocked in traffic parrot, will result in a different processing. Sometimes the mock data will be returned, sometimes the pass-through will happen to the real mobile network hardware backend. Okay. So how do we do this in traffic parrot? How do we implement this in traffic parrot? There's 3 steps. Create 2 additional mock queues. Okay, these mock provisions requests and mock provision confirmations queue, so that we can do this pass through. Then reconfigure the client to use the mocked queues. So we need to, the mobile onboarding service needs to use the mocked queues, and real queues are still used by the backend server. And the 3rd step is to create pass-through mocks in traffic parrot. So we'll need to create a mock for the mocked data and a pass-through mapping in traffic parrot that passes through everything else. Okay, those are the only 3 steps. Okay, so let's have a look at how we can do that in traffic parrot. First of all, what I'll show you is how this mobile onboarding and mobile network hardware applications work together through the IBM MQ broker that I've got running locally. Okay, so let's open up the browser here, and if you go to traffic parrot on GitHub, you'll see traffic parrot demo applications, and these applications are there. You can use them and replicate these demos on your laptop if you wish. We'll be looking at the mobile onboarding microservice, which is this one, and the mobile network hardware microservice, which is this one. Okay, and the mobile network hardware microservice has got a README file here that details all the steps that I'll be showing you here, and that you can just copy and paste to run this demo that we'll be doing right now yourself locally. Okay. As you can see, this is a sample of applications for demonstrating how to create pass-through JMS IBM MQ mocks in traffic parrot. You need to set up this application, this mobile network hardware application, once you build it. There's some instructions here how to download the IBM MQ file so that it can connect this application to IBM MQ broker. In order to run an IBM MQ Advanced for Developers container image locally, what you need to do is run these commands. So you can actually run IBM MQ locally. You don't have to use your QA environment one, assuming you accept the license. So you need to read the license before you set this environment variable here, okay, when running Docker. I'll do that just now so I can show you. I'm going through these steps myself, okay. So I'm running the Docker image, and this Docker image ID, the container ID that will be running here, okay. You need to add queues for the application, so the provision requests and provision confirmations queues. I've already done that early, so I won't have to do this. And you should do this if you haven't followed this tutorial yet. And then to use traffic parrot as a pass-through proxy JMS IBM MQ mock, you need to follow these steps. So first of all, make sure IBM MQ is running. Well, we've just run it, you just saw it was running. Then we need to set up the mock queues. So let's set up the mock queues, and the mock queues are these 2 queues. Actually, first of all, let me show you this, how the mobile onboarding and mobile network hardware microservices work together, okay? So I'll start up the mobile onboarding microservice, the mobile network hardware, both are started. You can see the hardware is processing something, but there are no new messages. And let me show you how the mobile onboarding microservice looks like. It's got this very simple user interface, where you set a you send a mobile number that gets sent to IBM MQ, and then a response comes back through the provision confirmations queue, and we can see that we've received the confirmation from the mobile network hardware microservice or application, and it gets presented here to back on the mobile onboarding microservice. So what just happened was we've got the user interface here, and I'm a tester. This is arrow number 1. It sent a request to the provision request queue, but got consumed by the second application that was running locally here, and that application put a response to the provision confirmations queue, which got consumed by the mobile onboarding microservice, and this result gets shown here. And we can see that in the logs of those applications as well. So I scroll a bit further up in these logs, and we can see here that the mobile onboarding microservice was sending a request to provision request queue. This is what it looked like, and it got a response that looked like this, okay? And it got it from the mobile network hardware microservice because it received the request and created a response, okay? So this is how these applications work together. However, we've got an issue with the backend service. In this test environment, imaginary test environment, QA environment that I've got running here locally, if I send a request for data and voice, the response I get is unsupported mobile type. So our mobile network hardware does not support data and voice services, okay? Only voice only and data only are supported, okay? So what we'll do is we'll create a mock that does support this type, data and voice type, and everything else will not be mocked. It will be passed through to the backend server. Okay, so let's have a look at how we can do that. So first of all, let's follow the instructions so you can follow this yourself at home. Let's create the queues for the mocks. So these will be these mock provision requests and mock provision confirmations queues. Okay, so opening up a bash shell in that Docker container that's running IBM MQ locally. Run the command line tool for accessing IBM MQ, then defining all the queues with its privileges and exiting this bash. All right, so we got the queues running. In order to you need to follow these instructions. If we just go here, you need to follow these instructions to download the required file, which is all client jar. I've already done that earlier, and those instructions say how to install it in Traffic Parrot. You need to let me show you how to do the next step, which is in the main Traffic Parrot directory. We'll edit the properties file, and you need to set the JMS response transformers and include the JMS pass-through message transformer in there. Okay, I've already done that earlier, so it's this step. You need to edit JMS connections file and make sure the password is set there correctly to the one you've configured when running the Docker container locally with IBM MQ, and the one, if you're copying the R commands, it's the password is password with a 0 here. We're gonna start Traffic Parrot, and both of these applications, we've already done that earlier, and we're gonna create a CSV file in Traffic Parrot data directory. So we're gonna go to data CSV and create that. So we've got just one column and one row, mobile number 111.222.30.33. Okay, and this CSV file will be used as our database. You can actually add more mobiles here. Okay, so we got 2 mobile numbers in here. So this is going to be our mocked data. Okay, and now we'll create a JMS mapping in Traffic Parrot. So the request destination will be mock provision requests. So Traffic Parrot is consuming requests from the mock provision requests queue and putting them in the mock provisions confirmations queue. Okay, we're in this scenario, a mocked scenario. So JMS add edit, mock gets listen to messages on mock provision requests. The request priority will be 1, which means mocks will be returned first, and only if there's no mock found will be sending requests to the real service, passing them through to the real service. We need a request matching script, which means it will load up the data from the mobile's CSV file that we've just created. Oh, there's an error here. And where the mobile number in that the row is equal to the one in the request, and we'll compare it to the one in the request, and if that equals, so if there's a request message with a mobile number that's in that CSV file, this is basically what this means, we'll return a response to the mock provision confirmations queue. So return a response to provision confirmations, generate a dynamic response. So this is the JSON response body basically, and we're saying the status will be mobile provision. The mobile number, we'll get it from the request, same with the type. We'll generate a random device ID and we'll put in a date dynamically. And we'll also say add a JMS property called traffic parrot mock message, which will allow us to see that this is actually returned from the traffic parrot mock. You don't have to do this, but sometimes this helps if you want to look at the logs and make sure that the messages that are created are not created by the real system we've passed through the messages to, but they're actually mocked messages. This is optional. You don't have to do this, but some of our customers do it to help with debugging, for example. All right, so this is created. So right now we got this scenario implemented, okay? And I think we could actually test this, but in order to test this we need to configure the this application to connect to the mock provision requests and mock provision confirmations queue instead of the real queues, the provision requests and provision confirmations. And the way we do that is we stop this application, we change its properties, and we say use the mock queues, start it up again, it started, and now remember that CSV file had this number in it, so if we send this number to the backend, it will return a response. Okay, no, it's not working. Why is it not working? Oh, sorry, traffic parrot. We need to turn on the replay. Okay, so we got this mapping here. We need to turn on the replay, which means it's going to be consuming requests from local Docker MQ and replaying responses to local Docker MQ, looking at these mappings. All right, and yeah, we got a response. Okay, so that's good. So all of these responses are coming back from traffic parrot, yeah, and you can see that in the traffic parrot logs. That it creates responses on the mock provision confirmations queue and shows you actually how those responses look like, and it adds a property traffic parrot mocked with message true, which is quite helpful here. And we can see that also in our application here, that it receives messages from the mock provision confirmations queue, and it's got this body, so dynamically generated JSON message and a property, JMS message property traffic parrot message true. Okay, so this is the scenario we're in right now. However, only this number is mocked. Okay, remember we added it to the CSV file, so anything else will not be mocked. So let's say I do 444-555-666 and nothing happens. Okay, why is that? We need to look at traffic parrot logs again. Go to the very bottom, and traffic parrot says no match for this, right? And why is that? Returning default value because no rows with mobile number equal to 444-555-666 found in the mobile's CSV file, right? So this number is not mocked. Okay, so what do? Well, we can go to this scenario and at the same time say that any other number should be proxy to the real mobile network hardware service. And the way we do that is by creating another mapping in Traffic Parrot. So we need to create a mapping for Traffic Parrot to pass through the requests and pass through the responses back from the real service. So how do we do that? Going back to again to add edits. So pass through. Mock provision requests, consume things from mock provision requests and send them to provision requests, right? We set the priority to 2 because we want the mocks to kick in first and pass through only if the requests are not mocked. And we need to use the transformer JMS pass-through message, okay? And that's it. Oh dear. We need to stop the replay and save this. Okay, so now it's worked. So you can't add new mappings when the virtual service is running, okay? So you need to first stop the replay. So there we have it. So we got this 3 and 5 configured. Now we need 8 and 9 configured. So consume provision confirmations and send them to or pass through to mock provision confirmations. And the priority does not matter. You can leave the default because there's not mock involved in here. Just leave the default. Transformer JMS pass through, and that's it. So we can turn on the replay. And we've got both of these running at the same time right now. So let's test the pass-through first. So this should work now. And it does, right? We got a response. And how do we know it's coming back from the real service? We can look at the real service logs. And yeah, we see that it's returned a response, right? It sent it to provision confirmations. And then we can look at Traffic Parrot logs, and we'll see that Traffic Parrot has sent a response to the mock provision confirmations, and it was the one found on this provision confirmations, right? So this is the forwarded message, okay? And we can test that it's being forwarded by sending this number and asking it again for data and voice. So this should not work, right? Yeah, it doesn't work because the backend still does not support data and voice, right? However, we've got a mock configured with 111.222.3.3. Remember that one? That's our mock. It's this scenario. It's still running in Traffic Parrot, and we got a mock for the number 111.222.3.3. So we can send a data and voice request, and that's going to come back from the mock, and it's going to work. So we got a data and voice response, right? So what did we just do? We've eliminated issues with the mobile network hardware backend by creating 2 additional queues, putting Traffic Parrot and mock to create mocks of those responses and mocking some of the responses. So we've got a CSV file where you can add more numbers. Actually, you can have as many as you like. You can add more columns to create different types of responses, use the CSV file in the responses, etc., etc. There's a lot of things you can do there, but this is a very simple example just to demonstrate that you can have mocks running with pass-through at the same time, right? So even though we've got a mock for 111.222.3.3, 444.555.666, for example, will be passed through to the real mobile network microservice. So yeah, if you feel like this could be of help to your company, feel free to reach out to us. Looking forward to hearing from you. Thank you so much for watching, and yeah, stay tuned. Bye bye.